This afternoon we're going to be talking about strategies for securing code in cloud and on-premises. I'll go through what that means in a minute. My name is Lee Packham. I'm a senior developer advocate. I recently changed role at Amazon Web Services. I work primarily on developer tooling. So those are the things in the console that begins with the word code, as well as Cloud9, X-Ray, all the software development kits, and the cloud development kit. And I talk with customers a lot about strategies around building and deploying code. And with me I have Craig, who is a senior solutions architect who works with our public sector customers in the UK. Before we go into the talk itself, I just want to highlight a few related breakout sessions that are related to this talk. I'll leave this up for a couple of seconds, and I'll try and show it again at the end. Don't worry if you've missed any of these. So if there's no repeats of any of these left, that's absolutely fine. The talks all get uploaded to YouTube in a couple of days, like 2 or 3 days after they're aired. So you can go and find the talks there as well. Some of these will go a bit deeper than we're going to go in this particular session. So whereas we will look at networking and we will look at things like Git flow, we won't necessarily go really deep into those, so you might want to look at some of those sessions as well. So let's sort of start right at the beginning. Let's look at why we're having this session at all. Why are we giving this talk? Well, as I said, I recently changed role, and I was a solutions architect at AWS for about a year. And this is a story I would hear over and over again, which is that, well, almost everybody is using a version control system of some kind, right? Whether that be something like Subversion, or whether it be something more modern like Git. They are using something to store and manage their code. Okay, that's good. And they want to use the cloud, but they don't really want to move their code. Or actually, more commonly, the dev teams want to move the code, but their security teams won't let them. And actually, this was something I was familiar about as a customer, where I actually joined one organization and you did the typical thing that you do. You go around and you introduce yourself to different teams and departments. And one gentleman was sat with me and we were just having a coffee talking about information security, and he picked up my Mac and dropped it back on the table. And he said, "I don't understand why you DevOps people have Macs. Why can't we have Windows laptops?" The fact that he was asking that question means that there was a gap in communication. And so that's the kind of thing that we're hoping that by having some of the discussions we're going to have today, that you can go back and have conversations with your organizations about this kind of thing. But before we do that, it's really important to define some things. I've often found that when I talk with people, they have slightly differing definitions of different things, like source code, building. What do we mean by that when we look at it? Well, source code is the design of systems and software. Some people call it the software, but when you really think about it, in its raw form, it is the design. We make it high level so that we can read it, so that we can understand it, but it also contains the business logic of our organization. Right? So, for example, I used to work for an e-commerce company. It contained the way we calculated margin. Right? That's valuable intellectual property. Right? So what that is could be really important to an organization. In another company, it could be logistics. The way they manage logistics is the most important thing to them, and they don't want that to be outside of their data centers. They're concerned about that. But they want to use the cloud because they want to try and build software, and the reason why is because who remembers when builds used to take days? So a couple of hands go up. Now, right at the start of my career, I worked in an organization where we had a 40U rack of machines to do our daily build. I say daily build, it was more like a weekly build, because it took a day to wipe the thing, to reinstall all the Windows servers that were there, because it turned out the only way we could do reproducible builds was to wipe everything and reinstall all of Visual Studio and everything else, and then do the entire build again. And the build itself took a day. Building code, and the reason why it takes so long, and actually comparatively it takes a lot of CPU cycles now, is that it's the translation of that high-level source code into something that a processor can run. That's actually quite a complex task. The higher the level of the language, the more complicated that task is. Now, high level has changed over the years, but if I look at something like, say, C++, and those of you who know about metaprogramming in C++, so template classes, that's really hard to compile because a compiler has to figure out every iteration of how that class is being made. It basically has to regenerate the code of that class into all the iterations it could be used in to then compile it. That takes a lot of time. And that's where the clouds come in and why a lot of customers look to the cloud to build software, because it gives them the elasticity they need to be able to build that more quickly. So rather than having one 40U rack of machines, they can now spin up as many machines as they want, do the build in a speedier fashion, which means they can now change the way they do it. In other words, when you think about the fact you're doing like a build a week, well, you're going to bunch your changes together. It's really hard to be agile when you're bunching all your changes together and you're having to do one big build and then one change broke the smoke test you did after the build. But when you've got the cloud, you can start doing builds on every single commit. So every time a piece of software changes, every time a branch changes, we can now do a build because, well, we can just spin up some ephemeral infrastructure and then just tear it down again at the end. But also the way we deploy code has changed. The way we think about deploying code used to be about, you might create an MSI file on Windows, or you might create a deb or RPM on Linux, depending on your flavor. But more and more, customers turn to containers. Now, why do we do that? Why do we think about containers? Well, actually, it harks a little bit back to what I was talking about with that 40U rack of build servers having to be wiped every time we did a build. It's because if we think about an application and its environment, it contains more than just the code or the compiled code. And when I say compiled code, Java compiles down to bytecode and you need the JVM. So in this case, the code is the bytecode and the runtime engine is the JVM. Okay, fine. We also have all the dependencies that go with an application. So that could be, you could have in the start of my career, things like COM components, but these days, things like DLL, static libraries, stuff like that. And the versions of those and matching the versions of those is also really important to an application. And there can be interdependencies in those dependencies. It's why when you have a Node.js application, you have this very deep node modules folder so that every single component can have its own version of all of its dependencies underneath that tree. That's why that exists. But if you think about it, trying to bundle many of those applications together against, say, that same node modules folder becomes very difficult. So containerizing becomes very handy for that. Containerization, for those that don't know, solves that by creating a layered image. And it creates a layered image that means that it can run on the same operating system, but anywhere. What I mean by the same operating system, the same base operating system. So a Linux container can run on any Linux machine, and a Windows container can run on any Windows machine-ish. So it has to sort of match the exact Windows build for the Windows one. But the fact is you can then have a base image of the operating system that your application needs, whether that be Ubuntu or more popular things like Alpine Linux, to keep that really small, to make that deployment quick. And then on top of that, adding those runtime components that you need and eventually your application. What's good about that is you can then package that up and deploy it anywhere. And actually, I work with customers who do this and take that entire container and build it in the cloud and take it on premise. It's actually more common to see customers go, well, we want the flexibility of containers, but we need to run them near our mainframe, right? We need to run them near something that has to be in our data center at the moment. And they want to keep that latency low. And in fact, one retail customer I worked with last year does exactly that. They build their containers, then use Kubernetes on premise to deploy their containers. So now we've sort of defined sort of the source and the building and a little bit of knowledge around containers. Where does that really fit into a deployment lifecycle? And although I've represented this lifecycle with AWS tooling, you can swap any one of these out. So just because I've put AWS code commit there doesn't mean that you have to use AWS code commit. You could use GitHub. You could use another way of grabbing your source code. And what I mean by that is, you could use a code build step to grab your source code. In fact, I'll explain a bit about that later. You could use another pipeline tool to manage this. For example, there's a plugin for code build for Jenkins. So you could use Jenkins to run your pipeline and use code build for your steps. And we'll go into why that's really good and important in a minute. Code commit in itself, though, is more than just a Git hosting solution. It is serverless, so there's no servers involved with code commit at all. You're not having to keep that maintained and managed. It is a managed source control service in that respect. You still get to use all your existing Git commands, and you also cannot have a public repository in it. So it's a private repository solution. Now, one of the things that you can do with this is you could use it as just a mirror to keep a copy of your Git repositories nearer to where you're doing deployments, knowing that it's privately hosted, knowing that it's end-to-end encrypted, and knowing that you're only paying for the number of users that have access to it. Code build is a little bit different. Code build is a fully managed CI service. Yeah, okay, it can compile source code, run tests, things like that, but what it really is a hosted Docker container running solution. It essentially grabs a build image, which is a Docker container, and it will go ahead and build it. And it will just run that container, and inside there's an agent, which is available on GitHub, so you can go and have a look at that. But what that agent does is it just goes and runs against the buildspec.yaml file, which we'll have a look at one of those when we do a demo later on. And that buildspec.yaml will basically specify the commands that container runs. It also supports Docker in Docker, so you can go ahead and build Docker containers within it. And it also supports doing Windows builds. So some customers actually use it to do Windows builds. The good thing, though, is that you only pay for the number of minutes you're doing a build. So if your dev team's not churning out builds, reasons to do builds, then you're not paying for the service. You are only paying for the number of minutes it actually does builds. But we talked a little bit about containers earlier, and I can't help but think that the way we deploy code has changed. And if we think about the fact that we're deploying code using more containers now, the destination usually ends up being the packaging of it. And then we end up pulling it down using either Docker or Kubernetes or ECS. But the output of the build cycle, it ends up being, I've got a Docker container, I want to put it somewhere. And Elastic Container Registry is a really good option for that, even if you're then deploying the container on premise. As Craig will go through in a minute, the connectivity options allow for you to privately connect to Elastic Container Registry. You don't have to change any of your tooling to use ECR. You use existing Docker tooling to use it, so it's a standard Docker pull command. But it's still serverless, so you're only paying for the amount of space that your containers are taking up, rather than having to think about deploying EC2 instances and managing the software on those. So now that we've looked at some of that, I'm going to hand over to Craig, who's going to look at some of the connectivity options to securely connect to some of these services. And then we'll come back and we'll have a look at actually how some of this fits together and how workspaces and single sign-on tie into that.
Cool. Thank you, Lee. Hello, everyone. If you're thinking my headphones are broken, no, this is genuinely how my voice sounds. And this is actually the best it's been all week. So you can much imagine how it was on Monday when I first did this. How they understood me, I have absolutely no idea. So I'm going to talk about connectivity and networking. And you might be thinking, hang on, this is a developer session. Why is this guy talking about networking? But this is also a security session. And the first thing you need to know about security is it's a layered approach. So one of the layers is prevention. Now, how do we prevent, in terms of connectivity, how do we prevent a malicious actor? Well, we go through a least privilege approach. The least privilege we give to somebody, the least connectivity we give to somebody, the less attack surface they have. So on that, with that thought in mind, we're going to talk about what options you have for connectivity and go through those pros and cons and look at it through a security lens. And then private link and how that fits in with our offering of least permission or least privilege into services. Now, I put this a quick version, and that's partly because my voice is just disappearing, but it's also because this is an enormous topic at AWS. Networking is huge. There are whole tracks devoted to it, and there's lots of, you saw some of the stuff in the keynotes about new changes. So if you want to learn more about networking, again, Lee pointed out earlier, there's lots of resources on our website and on YouTube, and some of them I think are very, very interesting, especially the stuff about our global infrastructure. So I'd encourage you to have a look. So you're all used, when you first started out, to connecting to AWS over the internet. You know, the first thing you probably did when you started using AWS, you create yourself an IAM user, you know, downloaded the CLI because you're all developers, right? And then you thought, oh, I know, what should I do? I think I'll create an S3 bucket, so AWS, S3MB, and you put your bucket name in, hit enter. Then you went back and changed the bucket name because that one was taken already. And those are the first kind of things you do. You build out your applications with that. And this week, how many of you have been trying out the new services? And it's great, you can do that. That's the idea. But once you've built your service, then you might want to keep that private to you or the company you work for. So connecting that over the internet stops being such a great idea because you have to open up that service to the outside world, to the internet. And thus you're exposing that service to a much larger audience than you want to. And that's where site-to-site VPN and Direct Connect come in. They give you that private access to the application that you've built. And in your code also can give you the private application access to your code, which is where Private Link will come in later. And then if you're out and about, like you're at reInvent, and you still want access to your application, you have remote workers, then we can use Client VPN. So the easiest one to start off with, if you're working from an office, is to set up a site-to-site VPN. I'm going to cough, excuse me. Sorry if you heard that. Now that is a connection between your on-premises and your VPC, between a customer gateway, which is essentially a firewall or a VPN device, and then over to your virtual private gateway, and that sets up two links, tunnels over that connection, which those are done for high availability, so each into a different AZ, and that's going to encrypt the traffic between your on-premise and your VPC. So now you can close up any SSH or RDP ports you had open and just to have a private connection. And that's a really good place, right? So if you had an application you just want private access to, you can take your internet gateway and you can get rid of it. And that's going to really please your accreditors because now you can then when they ask the question, know what rules have you got in your firewall? You say, well, hey, I haven't got an internet gateway, so don't need a firewall there, man. What are you on about? The problem it gives us, though, is now, with no internet gateway, we can't access the services that you've built in for SNS and SQS and recognition, all those public services that are available through AWS. So how do we go about getting access back to those? Well, if we step back slightly and talk about Private Link, if you have many VPCs and you want connectivity between those VPCs, but you want to do it privately, and the same to AWS services, they need a method without using internet gateways to connect all that stuff up. So if we just think about services, then we can add in a VPC endpoint into our consumer VPC, which gives us private connectivity from that VPC through to an AWS service. As a sort of show of hands, how many people are using VPC endpoints already? About 50%, I reckon, slightly more. So for you guys, you might even be developing your own services on VPC endpoints. For the other 50%, then I hope that this is going to be really useful to you. So you create your VPC endpoint inside your consumer VPC for a particular service. And if you tick the private DNS box, then that's going to resolve any call to that VPC endpoint. The VPC endpoint might be for, say, something like code build. And it's going to resolve the DNS for something like codebuild.useastwest.amazonaws.com to that VPC endpoint. It's going to effectively spoof that so that you don't have to change your code and you can just carry on deploying the same codes you would elsewhere, but now it's going to connect over the AWS backbone. So there are two types of endpoint. There's a gateway and an interface. The gateways are for S3 and DynamoDB. And interface are for the 40 other services 40 plus other services that support VPC endpoints. And those interfaces are effectively elastic network interfaces which add themselves into your VPC, which means that if you're targeting them from outside that VPC, you can get to them without incurring the problem of transitive routing. And that actually can be quite important, as we'll come on to in a little while. Now, access, you can use endpoint policies, but in our case, when we're talking about potentially using them on-premise as well as within a VPC, that becomes a problem, because if you're using them on-premise, then you can't define a principal. You're going to have to do it anonymously. It's easy for me to say. Therefore, you sort of lose that fine-grained access. So a security group might be more appropriate. Now, I've put on this slide, I've put access from dev subnet in a 10-100 range. So if you know potentially where your build servers are within your server farm on-premise or another area, then you can just define that one subnet access to a VPC endpoint. So if you're just trying to restrict something to, say, an EC2 endpoint or potentially a code build endpoint, then you can just restrict the security group to that. So let's take the ones that we're specifically interested in this talk, code build, code commit, and code pipeline, and create those 3 endpoints, VPC endpoints, which is our private access, and put them into our VPC. So that now any EC2 servers within there can access those private endpoints without going to the internet. Now there's a link to a paper down there, Security Access Service AWS private link. That's really interesting. It's not too long, and I'd encourage you all to read it. If you haven't managed to take a picture by the time I've stopped speaking, then you can view these obviously on YouTube, as Lee was mentioning earlier, or you can see this presentation on the event page. One more photo. Okay. So we take those endpoints and we put them into the site-to-site VPN we created earlier. And now we have access from on-premise through to those VPC endpoints, and we're accessing the AWS services privately. We haven't had to create an internet gateway to access those services in the VPC, and we've sent all of our on-premises traffic over that VPN tunnel to access those services. But that only works for IP. It doesn't work currently for DNS. The DNS we did only works within the VPC and not from on-premise. So we have to add in a Route 53 resolver endpoint into our VPC. Now, this is going to get a little bit tricky on this bit, so you have to follow me through with this. But we create a private hosted zone within the VPC, and we spoof whatever we're after. So code build, again, to use that example, .useast.1.amazonaws.com. And then in the root of that zone, the alias, we point it to our VPC endpoint that we're interested in. So again, code build 1. We then set up conditional forwarders from on-premise to that Route 53 endpoint, and then when it gets queried from on-premises, it will go through, ask the Route 53 endpoint where that IP is, and it will be resolved to that local endpoint. So now you don't have to change your code on-premise, and you don't have to change your code within the VPC. So we talked so far about site-to-site VPN, and that's great. It's encrypted and it keeps it secure, but it's also over an unmanaged network. Yesterday there was, in the keynote there was an announcement about accelerated VPN, which limits the amount of unmanaged network you have to travel over a VPN, but you still do have that portion. So to run over a managed network and a private network, you would use something like AWS Direct Connect. This works by either, if you have presence within one of our Direct Connect locations, which there's a list on our website for her region, places like Equinix and Interaction as an example. Then you can just cross-connect, and you can ask your networking teams if they have that. But if they don't, then you can set up a connection through a service provider. Those take slightly longer because they sometimes have to dig trenches and wire things in and so on and so forth. But once you've done that, you then can get a connection across to Direct Connect location, and then you just cross-connect to us, and you establish a number of VIFs. Now, there's 2 types, private and public. A VIF ultimately is a VLAN, and you'd obviously, again, have to engage your networking teams to work with this. But a public VIF is going to allow you access to the public service endpoints. So if you still want to carry on using, or perhaps isn't supported by VPC endpoints, then you can use the public VIF to access those. The private ones have to be attached to a virtual private gateway, and they give you access directly into your VPC. What it doesn't do is it doesn't allow you to go from one VPC to another. So although they all run over the same Direct Connect, you can't route between the two. Direct Connect Gateway takes away the problem where you have many, many, many VPCs and many VIFs. So you can run up to 50 VIFs on a Direct Connect, but then you've got 50 VPCs to manage. Or sorry, 50 connections to VPCs to manage. And the other end of that network, you also have to manage, the networking team also have to manage 50 VLANs on the on-premise side, and that becomes a slight problem. So this way, we can have a single private VIF connecting to Direct Connect Gateway, and then that splits out into 10 connections to VPCs, which you can manage as you would anything else within AWS. And that can be across a region, and equally, it can be across accounts. So for those of you with multi-account strategy setups and shared services and things like that, then that makes a lot more sense. What we haven't been able to do so far is to be able to connect into VPC with that setup. But with Transit Gateway, you end up with a hub and spoke network, where your Direct Connect now connects into a Transit Gateway with something called a Transit VIF, and now you can connect between the VPC. So if you, in this diagram, I have a set of EC2 instances down the bottom there, and then I have a shared services VPC where I put those VPC endpoints. And now I can connect from both on-premise and from that EC2 instance account through to those VPC endpoints, which means only controlling or having to manage those VPC endpoints in one place. Transit gateways are regional constructs, so unlike Direct Connect, we can go across region. These are regional constructs, so you'd have to have one per region. And yesterday we announced peering between transit gateways, so you can set up connections between them. The other thing you can do is you can actually terminate VPN. So our site-to-site VPN that we created earlier, we can now terminate against that transit gateway. So now we have a kind of a hub and spoke thing where we have all our VPCs connecting in. Again, a shared services VPC potentially with those, again, multi-account strategy. And we can connect in our site-to-site VPN where perhaps you don't have Direct Connect, a temporary office or something like that. And that's gonna give us a strong, sorry, I'll go back a slide. That's gonna give us a strong network to actually expand out through. And if you wanted to actually then encrypt across the top of your Direct Connect, you can do so by terminating that same VPN on the transit gateway running over the public VIF. A public VIF sits on the external interface of your on-premise firewall and then terminates on that transit gateway, giving you encryption from end to end. That might be necessary for you. It depends what kind of industry you work in. In the past, I haven't done that for other companies because we didn't think it was that important. But if your regulatory or your security guys say that you should do, then that is an option, and many people do use that. And the last thing to bring up is AWS Client VPN. And this is where you can have some people working remotely, people working at places like reInvent, and they need to connect into something you've already built in a controlled manner. Now, this uses an open VPN-based client and establishes a TLS connection across the internet. It associates then with a subnet, and then you can actually manage where it goes, either through network access with Active Directory, or you authenticate with certificates. And Lee's going to show this in action a little bit in his demo. The only one that's not on this slide is AWS Workspaces, which also integrates with AD and can use a similar fashion when you're working remotely. And again, Lee's going to show that in a second. So that is a whistle-stop tour through networking. And I hope some of it is stuck in your head and you think, I'm just going to go away and find out about that. And for those of you who already seen or haven't seen Client VPN before, then again, I would urge you to have AWS Private Link before, then urge you to go away and have a look at that because you can create your own services as well as consume others. There's a couple of talks on there, and again, as Lee was saying earlier, these are available on YouTube, and those might be quite interesting for you to watch. And with that, I'm going to hand you back to Lee for building deploying code.
So we've looked at some connectivity options, and we've sort of talked a little bit about building code and how we can take advantage of services like Code Build to use the cloud to build our software in a more timely fashion, but in a repeatable and reproducible way, maybe into something like Docker containers. And for the rest of this, I'm going to focus a little bit more on code build. I'm going to look a bit deeper into code build because we've talked about connectivity like from on-premise into services, but we haven't looked about the services themselves, right? Because we just said, well, code build runs outside of my VPC, right? It runs as a service which is actually technically outside of my VPC. So in this example, I'm looking at an on-premise CI server. So using the many open source tools that are out there to build software, but I'm doing it on-premise. And I'm connecting into my VPC. And in there, I've set up those private links that Craig talked about, and I'm making use of code build. And I'm using code build to build a container, and then I'm pushing that into Amazon Elastic Container Registry. And then my on-premise servers can pull that back down from my VPC. The thing is, though, that code build is still talking to the Elastic Container Registry over the public connection to ECR. You can actually go further than that with code build. Code build a job can be defined in a way to say it has to run with it an ENI within, or Elastic Network Interface within the VPC. And this means that the code build job itself, all of its outbound connections, have to either go via those private link connections or anywhere that VPC can route to. This could be advantageous because then, when your security team talks to you and goes, well, how are you controlling the outbound network connections of your build jobs? This is one way to do it. Because then you're able to control whether you've taken the internet traffic through transit gateway through a central services VPC, or whether, in some regulatory spaces they might take it back on premise before it goes out. That's actually, I've seen some customers do that. But the options are then available. And you can still take advantage of the paying for builds by the minute rather than having lots of machines sitting there that you're having to wipe. But how does this fit into a flow that a developer might use? Well, let's simplify it a bit. I've taken code reviews out, and I've taken all the code review, peer review steps out, and I've assumed that my code doesn't need reviewing. So I can just push directly into master, or mainline as we would call it, but let's just call it master for now. And I do git push origin master, and my origin is code commit. Well, code pipeline can be notified of things that happen in source code repositories. Whether it be code commit or GitHub, it can be notified that a commit has been pushed into a branch and then trigger the build. This could then go through a flow where it grabs the source code, or it grabs that commit, and it bundles it and it puts it into S3. That's what code pipeline source action will do. It will put it into an S3 bucket. You might not want to do that. You might want to have your pipeline run a code build action that downloads it from an on-premise server, or does it a different way. But the code build action can come along and then actually run a job to build a Docker image. And then we can use the same code build job to push that into ECR. Once we've done that, on premises, we can pull that image back down again. And we can pull that over those private connections that Craig was talking about. And I think it's probably easier to show this in action than it is to talk about it on slides. So I'm going to flip over to the demo laptop and hit the button. Excellent. If I type W a second, can people read that text? Is that okay before I sort of continue? Does that sort of work size-wise? Cool. It's an important thing to check. So I decided to do this demo all in Amazon Workspaces. And Amazon Workspaces allows me to securely connect into my VPC over the public internet. It is a virtual desktop interface. It ties in with my Active Directory setup. But it's actually easier to explain my Active Directory setup and the way that's set up by logging into my workspace. So I'm going to do this in a little bit in reverse. So I've got an Amazon Linux 2 workspace. So I'm just going to try and remember my password and log into that. And I've got a Linux desktop here. I've actually deployed the pipeline that we're going to use for this already. And it's just restored the state of when I last logged out. So everything that I was doing before is still here, and I can run software that I'm familiar with. So anything that works on a desktop Linux environment will work here. So I've got Visual Studio Code, I've got Firefox, I've got some JetBrains IDEs, So everything that I would use day to day is available for me in this workspace. Now, one of the things I want to do is have a look at my AWS environment. And to do that, I've made use of AWS single sign-on. And again, it's easy to show you this in reverse by me logging into the single sign-on environment and then showing you how that's set up. So this is where I got the password wrong, right? Cool. No, I didn't. So single sign-on allows you to give your developers or other people access to AWS accounts and assume roles into those accounts. Single sign-on can be linked up to Active Directory or other providers, but what this means is that you can control access within your organizations into the sub-accounts that you have within there. So I only have one account, but I've given myself administrator and power user access. And you can see here I've got management console and command line or programmatic access, but we'll go through the latter in a minute, and I'll just click management console for now. And that just takes me straight into the account. So I haven't logged in using an IAM user. There are no IAM users in this account. It's only allowing me access into this via my single sign-on. And I know I'm in here because it's told me that I've logged in via a reserved role, because single sign-on actually manages the roles in the account for you. So it will go in and create them on your behalf, and then your users then assume them. Now, Active Directory. Let's start with the VPC first. We've talked a lot about connectivity and endpoints, so let's have a look at what we've got set up in here. I actually have a filter. It's a great feature that in the VPC dashboard to filter by VPC, because it changes everything down the left to only show stuff from that VPC. It's a very standard VPC. It's just got 2 public, 2 private subnets. It's got an internet gateway, got a NAT gateway against the private one. But it also has some VPC endpoints in it. So I've actually set up here some endpoints for S3, code commit, and Git code commit. So code commit is the code commit API, and Git-code commit is the Git access to code commit. And I've also set up access to ECR to go via the VPC. Now, conveniently, this workspace is in the same VPC. So we can actually validate that that's true. So if I go to, say, code commit, and actually just pick a repository and grab the clone URL. Excellent. And I only want the host name. So let's go look at the host name. And let's go back to the terminal. Let's go to a terminal that I actually want to use. Cool. And host, and put the host in. Well, that's cool. So that's a 10.0 address. So to reach code commit, I'm not actually going to go via the internet gateway. I'm actually within my VPC. There is no code going over an internet address. Okay, so I've got those set up. And if I go back to EC2 now, do that the right way around. Who else does this? Does open new tabs on every single service when they drop it down? Yeah. It's the right way. Until you run out of room for tabs. Let me just grab my VPC ID because that's going to be quite handy for this. Excellent. So in my VPC, I'm actually running a couple of Windows servers for my domain controllers. I've actually got a Windows domain controller and a backup domain controller, and I've got a remote desktop gateway so I can manage my users. So I'm not using a managed service for this. I'm actually setting it up in a way that you would typically see it on premise. As in, I've actually just got 2 Windows servers doing my Active Directory, or probably more. But the main thing is that I'm communicating with a normal Active Directory. But managed services like Client VPN and Workspaces and single sign-on need to be able to access that directory. So to do that, they use a service called Directory Services. And in Directory Services, there is a type of Active Directory service called AD Connector. And what AD Connector does is it sits within a VPC and can talk to any Active Directory that that VPC can reach. So if we look at the connectivity options that Craig was talking about, he talks about how a VPC connects back to on-premise. Well, that works with this. So if the network within the VPC can reach the network that contains the domain controllers, then you're able to link these two up. And then suddenly the services that take advantage of Active Directory, such as such as workspaces or single sign-on or workspaces, can now actually do that. So with that set up, that's how I logged into my workspace. My workspace is actually just linked up with an Active Directory user, and I'm able to log into my workspace. And single sign-on, again, I'm able to log through. And we've checked that those endpoints are there, and we've checked that we're actually in an environment that means that I'm not going to push code anywhere I shouldn't push code. So let's push code somewhere. I noticed that I'd got a code commit repo called Docker Pipeline, and that was actually very familiar to me because if I go back here, that's what I'd created. I created a service called Docker Pipeline. Now, all that this does, I built it using the AWS Cloud Development Kit, or CDK, and it's a pipeline that has a code commit source action that I described earlier, then does a build, and I'll go through what the build does. And then what we'll do is we'll connect to a server that's outside the VPC, but VPN'd in, to be able to pull that image down. So what we need to do is we need programmatic access to AWS. Just because I'm in a workspace inside a VPC doesn't mean I have permission to do anything. Excellent, I don't. So the token I'd used previously is expired. So to get a new token, if you're using the current release version of the AWS CLI, i.e. V1, you have to do it via the browser. There is a current preview version of V2 which allows you to do this programmatically in the CLI, but for the purposes of this demo, I've stuck to the current version of the CLI. So if I want to do it using the single sign-on console, it conveniently gives me a list of clickable areas with all the tokens in. So I can just go, I want to copy those credentials, and then I can go back to my console, paste the credentials in, and now I'm logged in. And I'm logged in using the same role that I logged in on the console a minute ago. Now that I've done that, I can actually now think about pushing some code to code commit. So there's actually a project that people might not be aware of called Git Coco, which is available on AWS Labs. And what Git Coco does is it allows me to really quickly connect to code commit repositories rather than having to configure Git to use the authentication command in the AWS CLI. It does it for me. So it allows me to just do git coco ls, and it should list the repositories that I've got. And then I can actually go clone Docker pipeline, when I type Docker correctly. Having a keyboard at this angle is sometimes hard. Git coco clone, and it will go ahead and clone and will configure that repository for me, but quite rightly it's pointed out that it's empty. So conveniently, I have some code to copy into this repository, and then we're going to have a look at it. My turn. So all I have here is a Docker file, which just says, get me the latest version of Nginx, and add a custom index.html to it. And that index.html is very small. It's just a hello reinvent. Browsers don't really need the HTML head tags. Body tags are enough. Actually, not even body tags. I could have just put the paragraph tags in. It would have still done the right thing. The point is I wanted to show that we're just going to add an index.html that we can load up. The build spec is what we're actually interested in. The build spec lets me specify the version of Docker I want. And then you can see here we're going to install Docker, and then we're going to log into Amazon ECR using the command that is available to do that. For those who don't know, the $open bracket in bash or standard sh means execute the commands outputted by this command. So it outputs a number of environment variable settings and does that for you. I'm then going to build the image, tag it, and then push it. So with that, let's do that. So we'll just do git commit -m, initial commit. Oh. And then we'll push that. And then we'll have a look at what's going on behind the scenes. So let's go to code pipeline. And it's literally, no, I want the code pipeline, not the repository, sorry. There we go. Cool, it's in progress. So there's my source action, and it shows me that it got the source code, and it says that it got it from code commit and then its initial commit. And it says it's running a build, and I can click through all the details of that and see that it is indeed running the build. And I can also tail the logs of the build. So at the moment it's provisioning the instance it's going to use. And then once it's provisioned it, it will actually execute the commands that do the build and then push it into Amazon ECR. Excellent. There we go. So the build has now succeeded. I have the output of the build. I have the output of all the Docker commands that we use to do it. But I can see that it's done the build. And if I go to ECR, I will see that I've pushed very recently an image into ECR. Let's have a look at the other side of this. Let's pull this image somewhere. So let's get some fresh credentials. And go to a terminal. And excellent. This instance is outside of everything else. Now, I have to know it's currently logged into the client VPN, so I'll stop that for a second. So this machine is outside of the VPC. It's so outside of the VPC that it's actually in my default VPC. So it's in a public subnet, and I didn't want to do a site-to-site VPN with this box. I just wanted to have a single connection in. So actually, I use client VPN for that. And if I just quickly check access to ECR right now, it's going through public IP addresses. And that's because I'm not currently connected over the VPN. Now, as Craig mentioned, the VPN is a standard open VPN, and I actually used the configuration that the console spits out. But we can see that it's a standard looking open VPN configuration for those of you who've used OpenVPN. And if I start that service, wait a couple of seconds for it to log in, and now do that host command again. Well, let's wait a little bit longer. There we go. Now that's connecting over that VPN. So every time I go to connect to those endpoints now, it's going to go over that VPN into that VPC to connect to ECR. I'm not connecting to ECR over the internet. So let's go ahead and actually pull. Well, I can't pull the image down yet. I need to actually log into, yeah, cool. So just because I was in a workspace doesn't mean I can't copy text out of my VDI. So I can copy those credentials out of the VDI and then actually use them in this session. So let's go ahead and do a pull, or not. I forgot to do the important bit. There it is. Cool. That's pulled the image. Let's run it. Cool. Let's prove it's there. Excellent. Let's curl against it. And there we go. So what that's shown is that I haven't pushed that code over any public interfaces. I've used wholly private interfaces within inside of VPC to manage that code, to then manage that Docker container, and then pull that Docker container down. So that concludes the main talk for today. And I hope that was a useful tour of the kinds of things you can do using private link, using things like workspaces, Active Directory, single sign-on, and the kinds of ways you can go back to your organizations and show the different ways that information security teams might like to still be able to use the cloud with and still keep their code secure the way they want to and the way that their regulators or accreditors need to. Before you head off, I just wanted to highlight that a lot of this kind of content, including the content around networking discussions that Craig mentioned, as well as the other DevOps topics that we've gone through, are available on the aws.amazon.com site under training and path developing. And there is a specific path around DevOps in there. It covers things like certification, but it also covers a lot of the tooling and networking that we've done. With that, I want to say thank you. Thank you again for taking some time out of your very busy reInvent schedules to come to this. And we've put our Twitter handles up here. That's on purpose. Please feel free to reach out to us if you have any questions or any comments that you'd like to add. And the last but not least, please fill in the session survey in the mobile app. It's really important to us. I'm one of the track owners, and we actually use that information to improve reInvent every year. So please take the time to fill that in, as it allows us to improve on the content every time. Thank you very much, and have a good rest of your week.